that we leverage as OT pen testers, assuming that we compromise the enterprise environment, we get domain admin. Domain admin is not always the key or dependent on success. So it just makes things easier. So first thing, we get domain admin, and let me go back. Okay, thank you. Cool, yes, much better. Well, I'm actually a little bit ahead. So here's the remote access architecture. So just going back a slide, you have RDP jump servers, you have remote access proxy or VPN gateway. So these are the most three common types of remote access. Like I said, there could be a jump server in the OT DMZ, sometimes it's double hopped, but this is kind of key as an OT pen tester to know what type of remote access people are using to get in, because that will change our tactic. Okay. So this is like a basic standard IT type of attack, but it's actually I kind of want to highlight it because it's actually pretty interesting. So assuming we get domain admin in the enterprise network, the first thing we do is we pivot to an end user's workstation that remotes into the OT DMZ. And of course, we also look for the RDP saved credentials. And if you think about like these operators, if they're logging into the OT DMZ 5 days a week, and they don't want to type in their creds every single time they RDP in. So of course, you look at the desktop, you might find a .rdp file, and using something like sharpdp API or Mimikatz, you can harvest these clear text credentials. But if they're leveraging multi-factor authentication, that would prevent us from masquerading as these users. But we also like to keep this in our back pocket because the chances that once they're in the OT network, there's a good chance that these creds will work again. So like cred reuse is definitely a thing between IT and OT. Okay, another like kind of low-level attack is group membership. So again, once we get domain admin, we look at the groups that these OT users are associated with, and we just add ourselves to those groups, all the groups. And sometimes, just by doing that, we can access the same resources that they do. But again, if multi-factor authentication, that would prevent us, but we'll just use that later. Okay, so two like kind of low-level, just general type of IT attacks, and now we're getting into something a little bit more interesting. So I'm not sure if any of you heard of Seth RDP, but this attack it's a fun attack to do, but it's very limited as far as the type of environments we can leverage this. So what's interesting about this attack is that it intercepts remote desktop credentials as an end user attempts to authenticate to a jump server. But it only works in like usually small environments like wastewater treatment plants or just very small like organizations, because to pull off this attack, you have to be in the same subnet, and the workstation and the jump server also has to be in the same subnet. So you're talking about like a very small organization, but this is pretty fun attack because you could just run this man-in-the-middle attack and gather clear text credentials. Again, if there's multi-factor authentication, that would stop us from pivoting, but we can like keep this in our back pocket and maybe we reuse the creds later on. Okay, so this is where like the fun stuff happens. This is probably the most common technique that we use to pivot between IT and OT. And there's a few reasons why. It's actually very easy to pull off. There's not a whole lot of requirements. And like it bypasses like multi-factor authentication. So again, assuming we have domain admin, we find the users that like operators that remote into the OT DMZ, we pivot to their workstation, and so one of the requirements is we have to have an NT authority system level shell, and that's pretty easy to do. There's multiple ways to do it. You could use Task Manager, you can use PSExec. We normally just upload PSExec, spawn another shell as NT authority system. And then the first thing we run is query user, like so what users are logged on to that host. If it's a jump server on the enterprise, it's not at any given time you can see at least 12 different connections. So jump servers, there's a lot of connections we can see. If it's an end user workstation, it's probably just one session. But with this attack, what we do is then we find the user that we want to hijack, and we run like tscon.exe, and the session ID, and then boom, we have their session. We just like bump them off, and now we have their connection. So we're just piggybacking off of their remote access process. So they're going through the whole remote access two-factor authentication. They're going to jump server or remote access proxy, and then in some situations they're even pivoting to like some engineer workstation. So we don't need to know what their password is or know the two-factor authentication. We just bump them off and we have their session. The thing about this attack is it's not very OPSEC. It's actually like non-sec. It's we're bumping them off. But usually they think it's like a network connectivity issue, but this type of attack we usually collaborate with the end user, because if they're like an operator doing something very important, we don't want to just bump them off. So we let them know beforehand, hey, we're going to run this attack. Are you okay with that? And then we bump them off and take over. But again, it's not very OPSEC. Like it's something, if you try to do this as a red team, someone would know. So this leads me into the next attack. Remote desktop shadowing. So this is also like another favorite of mine. It's very similar to remote desktop session hijacking, but you don't need to have a NT authority system shell. All you need is the admin, and you have to make a edit to the registry. And then same thing, you can run query user. If you're on a jump server, you'll probably see over a dozen connections. If you're on top of workstations, this is usually the end user's connection. And then we will run mstsc.exe, which is RDP, or you can run shadow.exe. And with the no consent prompt, this means that the end user wouldn't know that you're shadowing their session. So that kind of makes it OPSEC. So once we run this command, we would have like a view of their desktop. And like again, they wouldn't know that we're viewing their desktop, but on the flip side, it's if we run commands or move the mouse, they can see that. So not very OPSEC, right? Again, we'd work with the end user to let them know we're going to run this attack, but it's not. We can't do a whole lot if we want to like hide our activity. So this kind of leads into like the next attack. This is OPSEC. This is actually very, very OPSEC. So hidden desktop or HVNC. So again, we have a domain admin on the enterprise network. We pivot to a end user workstation, and if we're using Kobo Strike, we can run hidden desktop, which is it's an open source tool by White Knight Labs. There's also like commercial tools from OST and Fortra, but the main concept here is that again, the end user is logging into the OT DMZ, or they're logging into like their engineering workstation. And once they have gone through the connection process, we would launch HVN's hidden desktop, and then we would be presented with is that better? Yeah, we would be presented with another UI of their desktop, but we can run commands, open up prompts without them seeing our activity. So this is actually really hard. This is a nice trick. So we're pretty much piggybacking off of their connection into the OT DMZ or even lower. And yeah, it bypasses two-factor authentication. Okay, next. So this is unfortunately something that I've encountered on many engagements, and it's usually larger organizations. But so in situations where like an organization is relying on top IT to manage network infrastructure, or even worse, like a third party to manage their network infrastructure, unfortunately, sometimes they leave it open to like from like the enterprise to the OT. So like it's a very implicit, bless you, implicit rules. So like, for example, if they have implicit firewall rules and they allow access to network switches, routers, management portals, to the whole enterprise, this is something that we can leverage to access these like these interfaces like over SSH or Telnet or web. And it's really sad because like, it kind of bypasses their whole remote access design. And so it's not just the router switches or firewalls, it's also other like miscellaneous devices. Like one common one is BMC devices. So like think iDRAC or ILO or UPS devices. So what I have here is like a UPS interface over Telnet, and then I can enable SSH, and with SSH tunneling, I can pivot into the OT DMZ. So this is kind of like one of those things where, yeah, they just leave open to the whole enterprise network. And yeah, if you have SSH, and if you combine this with default creds, it's even worse. So miscellaneous stuff. Okay, this is my last slide on attacks. And I was like, kind of wondering if I should put this in here, because I almost feel like it's common knowledge. But the thing is, I see this so often, and it's kind of sad. But okay, so in situations where there's like a jump server in the enterprise network, and then they incorporate like two-factor authentication, they use RSA or whatever two-factor authentication, they forget that, like, so even if I have domain admin access, I can't remote desktop into the jump server because I don't have two-factor, right? So the client usually thinks, oh, this is great, you can get in. But they tend to forget that, like on Windows servers, like WinRM is on by default, or SMB might be open. So we don't need two-factor authentication to access these services. We can just use like Evo WinRM or PS remoting to access the jump server through a different port. And then we could just redo the whole attack chain, use RDP shadow, RDP session hijacking, or HVNC. So yeah, always put the jump server below the firewall and close off any ports. If it's meant to be just remote desktop, make sure only remote desktop is exposed. Okay, so defense detection opportunities. So yeah, easy to detect remote desktop session hijacking. Just look for tscon. RTP shadowing, look for shadow.exe, especially with the no consent prompt. That should be a very high fidelity indicator, because if you think about an IT support that's working with someone to troubleshoot something, they're usually going to ask for permission to take over their screen, so their desktop. So if someone's not using that might be a red flag. HVNC is going to be much more difficult to detect, because you're going to have to look at like API calls to like switch desktop or create desktop. That's going to be a bit of a challenge. Okay, so harden the DMZ defensive takeaways. So like a lot of the attacks that I mentioned, yeah, like we bypass two-factor authentication and all that, but there's still a lot of things that you can do. So first, secure remote access paths, the basics, multi-factor authentication for everything. So strengthen segmentation points. So one thing I want to see more often, I've only seen this top one engagement, unfortunately, but they had two jump servers, but they split the protocol from remote desktop to remote desktop over web. And funny enough, that actually kind of was pretty effective, because we could hijack the session that had like a standard remote desktop access, but once they switched to remote desktop over web, they're not using port 3389 anymore, it's using 80 or 443. And so we couldn't hijack that same session on the second server. So you want to separate, you want to change the protocols. So not just go with RDP over RDP. Hardened jump servers, like I said, you want to make sure that if you expect people to RDPN, only RDP is accessible. You want to put it behind the firewall. You want to NAT it. And of course, you want to enhance detection and visibility if you can, wherever you can. So look for like even IDs 4624, 4634, 4778. And so I'm a bit early. I actually have time for some questions. Oh, thank you. Yes, go ahead. Dual next. Oh, the question is why is dual next on the jump box bad? Okay, because that's so dual next on the jump box means like when an end user remotes it into the jump box, they have an interface in the OT DMZ already, right? So it makes it very easy for us to start scanning the network. You can just do an ARP. You can enumerate the OT DMZ much easier. You don't want it to be dual next. You want it to have an RDP into something else. Yeah, that would be very easy to enumerate. Any other questions? Okay. What was the beginning again? Sorry. Oh, yeah. Yeah, actually, I don't commonly see that, but that's a great idea. He said, do I recommend having separate identity stores between IT, DMZ, and OT? Yes, definitely. Especially like Active Directory. You don't want to have Active Directory between IT, enterprise and OT. In some situations I've seen, oh, like 5 minutes. Some situations I've seen, actually OT DMZ is workgroup devices, which makes it very interesting. But yeah, definitely separate identity stores between IT and enterprise. I mean, OT. Any other questions? Got a few more minutes. Go ahead.
What indicators of compromise would you snap for HP and CD? Like especially with build happening?
Yeah, that's why I like it so much, because it's hard to detect. It really is. So actually, I created a fork of this tool because most of the times on the OT pen test, we're not even using C2. We're living off the LAN. So this is where like something like YARA rules would come in. And I know I work at SE. I know how, for bigger organizations, YARA rules is not always the most practical thing to find API calls because it's a lot of resource. It's very resource intensive, right? So, but yeah, you're gonna, for this attack, you're gonna have to detect the C2 beacon first. So that's your best bet. Aaron, go ahead. Okay. So yeah, suspicious SMB pipes. That's a good one. But again, like huge organization, that may be hard to, it's like a needle in a haystack, right? So, but yeah, thank you for that input, Aaron. Anything else? Okay, well, that's it. Thanks, guys.